In chapter 2 we basically talked about various different parts of our energy balance equation. uh, so energy balance equation should be familiar to you now. We have heat coming in, so remember this is energy crossing the boundary because of temperature difference. That is the basic difference of Q and W. And then we have work here. So this is work. Work can be different forms. For an example, shaft work, electrical work, or spring work. And then we have energy that is crossing the boundary due to mass flow rate. So remember, this side, left side of the energy balance equation, represents energy crossing the boundary of our selected system, and the right hand side have energy within the system. So this U is the internal energy of the system. This kinetic energy and potential energy is the kinetic energy and potential energy that is given for the system because of the movement of the system. So remember, we talked about different forms of energy, forms of work. So one thing that you have to especially remember is electrical work. When you're calculating electrical work, for an example, let's say we have 2 volts and 4 amperes. So 2 volts and 4 amperes, that means we have 8 ampere volts. So ampere volts is a unit of measurement of power. If you want to convert ampere volts into our conventional units of power, you have to use this unity conversion ratio. And also remember, when it comes to work, boundary work is extremely special type of work. We are learning the reason in chapter 4, because delta H is equal to delta U plus boundary work. You cannot add any other type of work to U and call it H, but you can add boundary work to delta U to get the delta H. We are learning about that in chapter 4 again. So remember, boundary work is a very special type of work. That is why we write different types of work separately in our energy balance equation. Also remember, U, internal energy, is a combination of other energies. We normally don't consider these parts of U in our problems, but it's important to remember the difference. Sensible energy is the amount of energy that is given to the system because of the temperature change. For an example, like if you heat water and if you observe a temperature difference, that is because of sensible energy. And if you see a phase change, the temperature doesn't change, so the heat is hidden in the system, we can say. So that is what we call as latent energy. And chemical energy is the energy that is stored within the bonds of a molecule. And nuclear energy is the energy hidden in the nucleus of the atom. And if you take all of these together, we call it as internal energy. And we talked about sign convention. We talked about modern sign convention. In the modern sign convention, you have a positive sign in between Q and W. Remember that. And in modern sign convention, Q coming in and W coming into the system is considered as positive. In the formal sign convention, this is the one that we prefer to use in most of the examples and answers that I give you. Also in our equation sheet, we have Q minus W as in the modern sign in the energy balance equation. So that when you see this negative sign, you have to remember that we are using formal sign convention. And in formal sign convention, heat coming into the system is considered positive and work going out of the system is considered positive.